All right, so let's talk about the balancing of chemical equations. And we're dealing with chemical equations and balancing them. We have to make sure we adhere to a simple rule, and that's a conservation of matter. You might know it as a conservation of mass. And that is saying that matter is not created or destroyed, it's only changed. Okay, so we want to make sure that we don't magically make up new elements as we're dealing with chemical equations. We want to make sure whatever we have on the reactant side is exactly the number of particles we have on the product side. And so let's talk about let's put into action what I'm talking about. Let's deal with this. We have this written chemical equation, and I'm going to put that into a skeletal equation, or the actual chemicals. So we have liquid carbon disulfide. Okay, so that's CS2. It's a liquid, so we have to denote that. Reacts with oxygen gas, and oxygen gas is one of our diatomics, so we're going to say it's O2, and it's a gas. Yields or produces carbon dioxide gas and sulfur dioxide gas. Okay, great. But we want to make sure when we're dealing with chemical equations that the number of particles or the number of elements that you have on the reactant side equals the number of elements you have on the product side. So let's go ahead and check that. We have carbon, sulfur, and oxygen here, which means we should have strictly carbon, sulfur, and oxygen on the product side. Okay. And we want to make sure when we're dealing with these that we do not change the actual molecules themselves. We only change the number of molecules that we have. So the only place I actually want to put numbers and make changes is the place before that. We call those coefficients. Okay, so on the on the reactant side, we have 1 carbon, we have 2 sulfur atoms, and we have 2 oxygen atoms. On the product side, we have 1 carbon, 1 sulfur, and 2 plus 2 is 4 oxygens. Okay, great. So now, right now, before we even balanced it, we notice that we have an uneven number of elements on either side, so make sure they're even and balanced. So right now the carbons are balanced. We have 1 carbon on the reactant side, 1 on the product side, so we're good there. Looking at sulfur, we have 2 sulfur atoms, and we have 1 sulfur atom over here, so we have to change that. The place we change it is before the compound, right here. So I have 2 on that side, I want to make 2 on this side, so I'm going to put a 2 here. Okay, that tells me I produced 2 sulfur dioxide particles. So 2 sulfurs, but then I also changed the oxygen. So we have 4 now, plus that other 2, which is 6. Okay. So now our carbons are balanced. Check. Our sulfurs are balanced. Check. We want to make sure our oxygens then are balanced. We have 2 on the reactant side and 6 on the product side. I'm going to change that. So over here, we want to say there's 3, we need 3 oxygen gas particles to react with 1 carbon disulfide particle. So we're going to change that to 6, and now it's 1, 2, 6, 1, 2, 6. We are good to go. This is completely balanced. Great reaction. Okay, let's do something a little bit more complicated. Going over here, before we dive into this equation, this reaction we have on the board, which is potassium chromate plus lead 2 nitrate, yields potassium nitrate plus lead 2 chromate. We want to make sure we balance this properly, but there's a lot of a lot of atoms in this. So we want to make sure this is easy on ourselves. Before we jump right into it, we should notice a pattern. We have a chromate molecule or polyatomic ion here. We also have a chromate polyatomic ion here. I can just keep those together. I also have a nitrate particle polyatomic ion here and a nitrate here. I don't have to separate the nitrogen and the oxygen out. I can keep them together since they're on the reactants and product side both. So I'm going to separate everything else out. Potassium, chromate, lead, and nitrate. Oops. And I'm going to do the same thing on the product side. Okay. Okay, so I have 2 potassiums, 1 chromate, 1 lead, and 2 nitrates. I have 1 potassium, 1 chromate, 1 lead, and 1 nitrate. Okay, so let's deal with the first one first. Potassium, we have 2 over here. We have 1 over here. I do not want to put a 2 within the compound itself. I do not want to change this at all. I want to put it in front. So I'm going to make that 2. So I'm going to have 2 potassiums over here, but that also changes my nitrates to 2. And let's see. So we have 2, 1, 1, 2, 2, 1, 1, 2. Looks like the whole thing's done. We are good to go. Let's look at something a little bit more complicated. Let's look at this reaction here. So we have C3H6 reacts with oxygen gas to produce CO2 plus H2O. All right, let's do what we've been doing, writing our elements out. C, H, and O.